Hey, so hello and welcome to this video tutorial for E411 Statics and Dynamics of Simple Mechanisms. So we have this incredibly simple problem here. It states a bus starts from rest with a constant acceleration of 1 meter per second squared. Determine the time required for it to attain a speed of 25 meters per second and the distance traveled. So we don't really need to learn all that much university level theory to understand and do this problem. We could model the way that the bus is moving. So let's draw a velocity time graph here. So it says the bus starts from rest and has a constant acceleration of 1 meter per second squared. So presumably its velocity over time will look something like this, right? Where it starts at 0, and let's pick a different color here. It starts it ends at 25. Okay. And its acceleration, or every 1 unit of time, it's increasing in velocity by 1 meter per second. So every 1 across, we go 1 up. It's asking, determine the time required for it to attain a speed of 25 meters per second. I don't feel like I need to write out a calculation here. I'm just going to say it's going to take 25 seconds. Makes sense. Let's say 25 seconds equals time, or time taken, or I could even describe it as time at v equals 25, something like that. I'm using the subscript here. Okay. The second part of the question is asking what is the distance traveled. So to calculate the distance traveled, note that we understand that speed equals distance over time. I feel like this is a well understood concept. So if speed equals distance over time, we can then we could therefore say that distance equals speed times time, right? And notice on the left we have a velocity time graph, and we understand that distance equals speed times time. Hopefully this can help us comprehend how the area under this curve here, so this area that I'm trying to shade here, is equivalent to the distance traveled. Okay. So in this instance, we have a triangle, a right-angled triangle. If you want to calculate the area of a triangle, you would say then that is equal to half times base times height. So in this instance, we've got half times base, which is 25 in this instance, because this is a 25-second period, times height, which is also 25. And this comes out at 312.5 meters. 312.5 meters. Okay, and there you have it. So this is how we might comprehend the problem, just kind of using common sense here. We can also make use of these kinematic equations that I'm hoping you guys are familiar with. Once we've determined that the time taken is 25 seconds, you then have everything you need to calculate the distance traveled, right? Understanding the notation here, that u is equal to or is equivalent to initial velocity. That v is equal to final velocity. Apologise for my handwriting. That, what else have we got here? T is equal to time, is equivalent to time. That A is equivalent to acceleration. And that S is equivalent to displacement. I'll move my head out of the way. Displacement. So what I'd suggest to you, this is a very simple problem, but if you want to understand it in an even more thorough way, I would suggest calculating S using all of these different equations, right? So you could calculate S here, where U in this instance is 0, since the bus starts from rest, right? V is equal to 25, and A is equal to 1. In this instance, and that time is also equal to 25, right? So you could use these values and use them for equation 1, equation 2, equation 2, equation 3, equation 4, and equation 5, right? And see what you get for a value of S, and you should always find that your value for S is 312.5, okay? Awesome. So thank you very much for watching. If you have any questions or comments about that problem, please leave them in the comments.